So, hello everyone, welcome back to our channel. Have you ever wondered what happens when you transfer money from one bank account to another? How does one system ensure that your money is not lost or duplicated? The answer all lies in the ACID properties. They are the foundation of reliable data-based transactions. So in this video, we'll cover everything you need to know from what is ACID property, what are ACID properties, and why they matter. Along with we'll also discuss some real-world examples like banking, e-commerce, healthcare, and also we'll discuss how database ensure consistency even during the system failure. So, did you know without ACID properties, Amazon orders could get duplicated, bank transactions could fail, and patient records could become inconsistent? Stay tuned to understand how database prevent these all disasters. So, we also, if you want to deep dive into data analytics and are serious about learning SQL, Python, data analytics, Power BI, Excel, statistics, everything for free with 20 plus hands-on projects. So do subscribe to our channel because we are going to going in depth for data analytics series. So if you have not subscribed, do subscribe to it now. All right, let's dive in. So what is database transactions? So basically, a transaction. What do you mean by transaction? A transaction is a in a database is a sequence of operation performed as a single unit of work. A sequence of operations. There are so many operations, right? Like you might don't know if you are doing a payment. We are not aware about the backend work that has been going on behind that, like how the transaction starts and from one account to another account the money got transferred, but there are so many backend things involved in all that which we are not aware about. So transaction in a database language is called as sequence of operations performed as a single unit of work. So you can just remember it as sequence of operations performed in a as a single unit of work. As a single unit of work it is performed, but it is a sequence of operations. So this way you will be easily able to remember it. So now let's uh, tell one example. So imagine if you are transferring rupees 1000, let's say 1000 from your bank account to your friend's account. Then your account should be debited by rupees 1000 and your friend's account should be credited to 1000. If anything fails, network issues or power outage or anything, the transaction should completely roll back, right? As you might have seen that if you are paying to some custom shops or some friends, and if it is getting cancelled, the money will come to you, right? It won't be stuck in somewhere in middle, right? Either it will come to you or it will go to the receiver's account. So this actually process is atomicity that we'll discuss further. So a transaction must be processed completely or not at all. That's where acid properties come in. Now let's discuss acid property one by one. So acid property basically stands for ACID. There are four letters as you can see. Like for A stands for atomicity, which means all or nothing. C for consistency, I for isolation, and D for durability. Atomicity means what? Either all or nothing. In simple term, I will write all or nothing. Either everything is performed or nothing is performed, right? Consistency means it maintains database integrity, but we'll understand deep into that later on. Just writing maintain data integrity. Okay. Isolation means what? Isolation means transaction don't interfere. For example, one more than one transaction happening at a single time, right? So the one transaction should not interrupt other. No interruptions, right? Transaction don't interrupt, right? So yeah, okay. Durability means permanently saved changes. For example, I will give you wait. Changes are permanent. Let's say for example that you have sent 1000 rupees to your friend's account. Initially you both are having 1000 you are having 2000 rupees and your friend is having 3000 rupees, and you have paid the 1000 rupees to your friend, right? So how much is left with you? With you 1000 is left, and with he will get 3 plus 1 4000. So after that, the changes should reflect in the database, and it should be the count of the sum of all the actual process should be the same. For example, both should equal to 5,000, right? So this process again comes under consistency, and the first process that I told is under durability. Durability means the changes are permanent. I mean, permanently this should be saved in the database. So I hope you got it. Now again, we'll go deep into the AC property. Not to worry if you haven't understood anything. So now let's understand a little bit more on atomicity. So okay, so basically atomicity, we'll understand more about that. For example, let's say a banking system. A banking system. What you transfer 1,000 to your friend. For example, you are a person A, and your friend is person B. Both are initially having, you are having 2,000 rupees, right? Your friend is having 4,000 rupees. So you transfer 1,000 to your friend. So he will get plus 1,000. So total 5,000, right? And currently how much total is there? 6,000. And now you are left with 2,000 minus 1,000 is equal to 1,000. And your friend is left with 5,000. So now again, if you sum it, how much it is? 6,000, right? So this is known as consistency. Consistency definition I will tell you. Consistency is basically that the sum of both, I mean the transactions before the transaction and after the transaction should be same. Like before transaction statement and after transaction, the sum should be, sum of all the things should be same. So this is known as consistency. So because it's a consistent, right? So for example, let's say while transferring these amounts, the internet went down, okay, right? Internet went down, and what atomicity will do, I mean atomicity process will do, for example, your 1,000 would be gone from your account, but your friend would not receive it, right? With atomicity, the entire transactions will roll back. Roll back means the entire process will roll back, and it will be come to your account only. So this is known as atomicity. Atomicity means either the transaction is done with entire process, like 6,000 is received, I'm sorry, or it is cancelled and rolled back. Roll back, right? So this is known as the property of atomicity. Let's understand with the real world importance. Uh, it prevents, partial updates and data loss. So atomicity will prevent a partial data losses. Now let's understand consistency. Consistency, I think I told, right? uh, it ensures that a transaction moves from the database from one valid state to another. It in other way you can say that the for example, I explained that the from one account you are transferring money to other account, but valid state to another valid state. For example, this is a valid state, that is 2,000 rupees, right? And again it is going to this valid state. Currently it's having 4,000 rupees, but the overall things are same, so it is consistent throughout the transactions. So this is known as the consistency. For example, you have an e-commerce store, and you buy a laptop from Amazon, then the stock should decrease from 10 to 9, right? There is a 10 laptop in the e-commerce database, and you are buying one database, so minus one, how much you are left with? 9 laptop, right? So stock should be left with 9 laptops. And if the transaction fail, stock should remain 10. It should not be somewhere it's stock, no, right? It will, if you are not able to buy, if it's cancelled, then again it will be gone to 1 plus, then again it will become 10, right? Because it will get cancelled means it will roll back, right? So this is how the transaction works. So many things are working in the back end, right? And real world importance will be that it will prevent inconsistent data, errors, incorrect records. I mean, the records should be updated, right? For example, you have 5 kg of apples and you are selling it. The customers should understand, right, that your apples are getting sold or not. Or else if it is sold already and you are not, your database is not updated, the customers will think that you are still having 5 kg of apple, right? So how they will try to buy it, right? And then they at last they'll get to know that you don't not left with any apple. So in this way, of course, you fail as a businessman, right? So this is again a use of database comes into picture. The database makes sure that the things are updated, and it works with the help of commit command, right? That rollback and commit. Commit means the everything are saved permanently, and we'll understand more when you come to which is the final step called as durability. So this is how it works. And now third step we will understand, which is isolation. Uh, let's rub it. So the third one is what is that? Isolation, right? So isolation. Isolation is basically transactions should not interfere between each other. Like for example, at one single time, so many transactions are going on. For example, you have a writing different transaction right here. So these both are transaction are going on at the same time, right? T1 and T2 transaction. So these transactions should not interfere these transactions. So this is done with the help of database property, ACID property, which is isolation property. Isolation property makes sure that transactions should not interfere. It ensures that multiple transactions around interfere with each other. For example, I already told, right? Let's say I am paying and you are paying at the same time. And it happens, of course, because we have billions of population. So at 1 second, every second, so many UPI payments are going on. So how it is make sure that it should not collide? It's done with the help of ACID property, which is isolation. Your property should not be matched with the other property unless it is committed. So after commit, it will be reflected, right? So unless it is commit, your system should not interrupt my system, my transaction. So it will also prevents the details to get leaked, right, from other the bank details or some other things, right? So it saves us from frauds as well. So for example, let's say movies also. If two people are trying to book a movie at the same time, right, and the seats are, for example, we have 200 movie seats left, and you and I are saving doing booking at the same time. So what it will do, it will serialize our transaction. Serialize our transaction will save our time, and it will maintain the integrity. I mean, for example, if you came first and started doing transaction, so the ticket will reduce to 199 because one is already in progress or it's almost done, right? So this will what it will do, it will maintain fairness and accuracy in multi-user environment. So in this way I can get to know that no, 200 seats are not left, only 199 seats are left. So this again plays a very important role. Now the final fourth step is durability. Durability, what does that mean? Durability means it ensures that once a transaction is committed, it remains saved permanently even if the entire team system crashes. It will commit it, right? Whatever you did, for example, we did so many systems here, right? Sending money to this customer, sending money to that customer, right? So many things happen in between, but it remains consistent throughout the process. So this is how it works. So now let's acid property, are essential for many industries. Let's explore some of them. For example, banking systems, e-commerce websites, healthcare databases, airline ticketing systems. I already discussed about ticketing system, right? Booking movie and all. So you make sure that the commit command is run and database, and we are doing these things, but there are so many things running in the background maintained by our developers back in back in framework. So these are all kind of acid property. I hope you got. I will again try to give you a brief idea about everything. So without acid property, this system would break, because it will again, for example, you paid someone but the transaction didn't happen and it got stuck in the middle. So if the acid property is not there, you won't be able to access everything. So now let's discuss the ppts that is over here. So as you can see, they have mentioned the acid transaction database, the contents and all. If you want me to share the ppt, you can just comment and I would be sharing with you people. So yeah, atomicity, as I already discussed this, right? And it ensures the either uh, either something is not completed or everything is done, right? So see, all or nothing is completed. For example, I already told, right? For example, you have done 2000 and the friend is having 3000. You send 1k, and then he should have 4k, right? And you should have 1k. So it is completed, right? And once it is read into database, again it is written. So it works like that. If you go more into computer architecture, how the things into bits work, you'll get to know everything. But as of now, we can just understand atomicity as the process in which either the entire process is completed or the nothing is done. Either the transaction is completed and the money got transferred, or it get rolled back. Roll back means it will come to your account, so that it won't get stuck in between. And now let's discuss second one, consistency. So consistency, what I told, I mean, it ensures data accuracy, accurate and reliable. So it just makes sure that the data is reliable and accurate. I just mentioned, right? For example, you sent some money, right? You have 3,000 rupees. Your friend is having 4,000 rupees, and you sent 1,000 rupees. So you are left with 2k. He is left with 5k. But still, if you count, it is 7k, right? The data is reliable and accurate. It is correct, right? If you count this plus, how much is this? 7k. This is 7k. So both are same, right? So the one more definition of this consistency is the data after the completion of transaction and before completion of target transactions. The both sum of both the data, I mean transactions, should be same. So you can see here it's same, right? And it enforces rule defined by business law, prevents partial update that could lead to inconsistency. It prevents from being the database inconsistent. So yeah, as you can see, consistency ensure that the transaction brings the database from one valid state to another. One valid state to another. One valid state is like you are having 3k. Another valid state is that your money gets transferred and your friend is having this much money and you are left with this much money. Again, it is written into your database, and again it is written in that database, your friend's one. So how it all happens like that, right? I hope you got it. Now, isolations that you can see over here. It ensures transactions do not interfere. I gave one example of T1, T2 transactions, right? If you remember, like for example, you are having one transactions, and your friend is having another transactions. So this both transactions should not interfere each other. So it what it will do, it will prevent data in inconsistency and in transactions. So many things will happen. So how it will protect it, it will serialize this, right? As you can see over here, they have mentioned it, that it will serialize it to prevent so many data losses and repeating transactions. So this is how they do that: repeatable, read, and serializable. With the help of that, they achieve this. And yeah, as you can see, changes made by one transactions are not visible to another until transaction is committed. I was discussing, once the commit is done, then it is reflected into the database, right? Before that, all both transactions should be differently running, right? Write operation, read operation, whatever operation is carried out on the database, on the transactions, all are separated from each other. Like you are paying something, I am paying something, right? So we both should be separated from the database. At the end, the database will be updated. For example, your bank balance will be updated, right? So this is how, what they mean, that the commit operation, once it is run, your bank will be updated with the new balance, right? For example, you have 5,000 rupees and you paid to some shop on 1,000 rupees. So, and I have 6,000 rupees, I am paying 1,000 rupees. Our both transactions are currently in separate state, but once the commit is done, you are left with 4, I am left with 5k, and then it is updated in the database. So how this is how isolation process work. And it also brings some privacy and security to the transaction. So durability of data, I already mentioned, ensure data is saved permanently. So once the transaction is done, once you have completed the transaction, it is saved in the database and the commit command is run. So once the commit is done, it is saved in the database for permanently until and unless you make more changes. And commit, and remember one thing: once you commit, it won't be rolled back. commit things are not rolled back. So for example, once the payment is done to your friend, the same thing cannot be rolled back. But yeah, he can make a new transaction, that is a different case. But again, then you have to start a new transaction. So yeah, this is how the database transaction reliability functions work. So the importance of database, of course, I mentioned data integrity will be maintained. It supports reliable transactions, concurrent, as so many people can to do payment at same time. So these are all kind of benefits and importance of using ACID property. And user trust as well. User can trust that your transaction will now be processed correctly. I mean, there's a privacy and security, right? So it ensures database remain stable, and all these properties are there. So yeah, this is all the importance. And real world application, you can see that banking system, e-commerce, healthcare, ACID properties are critical for financial transactions, prevents data loss and ensure accuracy. Data loss is protected, right? So I told no, like our mine and your transaction both are having isolations, following isolation property. So this is how it is protected. And healthcare also will save the sensitive data during transaction, ensure compliance with regulatory. So many patients will have critical data and sensitive data of patients, right? Their healthcare details, their everything. So it should be protected because those data are very crucial data. It might not sound, but the your health data is the most crucial data. I mean, even it is more kind of more important than even your bank details, right? Because this is sold at this data is very important, and the if the people will leak the data and they can make a very good money if you don't make sure that it's safe. So e-commerce also, it ensure orders are processed correctly. Like I told, right, that you are selling 20 pencils or pen. So the database should keep updating that how much pens or pencils are left in the stock. So this is done with the help of ACID property. Everything is done with the help of ACID property. So I hope you got it, and now we have come to the conclusions. So that's what as technology evolves, databases are becoming more adaptive, and the future trends of hybrid databases combining AC transaction with high speed NoSQL database management system, and blockchain smart contracts, cloud database, scalable, distributed, and secure. So understanding of AC properties is critical for developers, database engineers, and data analytics. So uh, so if you have not subscribed to our channel, subscribe for more things, because in our next video we are coming with SQL queries. We'll be solving so many SQL queries one by one, and also we are coming with other things also in that data analytics series, where we'll also study Python, Power BI, SQL. Of course, we are starting, and along with that we also cover some concepts of stats, and if required we'll also cover the cloud, AWS as well. So that's all for today's database deep dive. If you found this video helpful, don't forget to like this video. If you have learned something new, share it with your friends who are into database analytics, and comment below if you have any questions regarding this particular topic or any coming topics as well. Subscribe to this channel for in-depth data analytics series that we are bringing on this particular access our playlist, which is our data analysis in-depth series. Also, if you're serious about learning, don't forget to like, share, and subscribe. Share with your friends as well who are might be looking for a data analysis free courses, because we'll be doing 20 plus projects as well. So that's it for this video. See you in the next video.